Hello, in this video we will talk about when we ANOVA under the case with unequal sample size. So we know from previous video, so the ANOVA called analysis of variance is a hypothesis testing which is used to test the null hypothesis that the different population mean from different treatments are the same, are equal, they all equal. And if at least two of them are not equal, then this hypothesis H0 will be rejected and in favor of alternative hypothesis called H1, that at least two of the means are not equal. And very often we use equal sample size to do ANOVA. So under this case, the ANOVA's total variability of the data can be partitioned into two parts, SSA and SSE. So this is the SST, the total variance. Total variance is the summation of all observations against the grand mean. So grand mean Y bar double dot means the average for all the samples from all the treatments. And because we have equal sample size, so this SSA is called the variance of the factor or variance for different treatments. So this can be calculated with n outside of the summation because the equal sample size. Then each treatment's mean against the grand mean. Then take a square and summation for all the groups, all the treatments. And SSE is sum of error. Sum squares of error is calculated with the summation of the within group variation. So each observations against its corresponding treatment mean in each group. Then because n is the same, so we can use summation n and k here. So this is the equal size ANOVA and this table with a corresponding part and degrees of freedom. Then division of these two will get the mean of square, mean of sum of square. So the division of these two parts, the variation from the treatments and the variation from the error. So these two parts division will get sampled F value. So we use this F value calculated against the critical F value from F distribution with k-1 and kn-1 degrees of freedom. So these two degrees of freedom comes from the treatments and error. So if this value larger than this critical value, then the null hypothesis will be rejected. And in the case of unequal size, because in many cases the sample size for each treatment cannot be equal. But the previous analysis of equal sample size would still be valid if we slightly modify the sum of squares formulas if under the circumstances of unequal sample size. So here we use the SST with a summation of all samples against the grand mean. But here is from each group we use the sample size 1 to ni, then sigma each group, each treatment. And for the SSA, we also use treatment mean against grand mean, and take a square then times its sample size then we sum the overall groups. Then for the SSE, we cannot directly calculate, we just use the difference between SST and SSA. And for the degrees of freedom for these three parts, n-1 is for the SST, where n is the odd sample size. And k-1 for the SSA. This is same as before, because we have k treatments, because we lost 1 degrees of freedom for the grand mean, so k-1 for the SSA. And their difference, these two difference, equals n minus k for the SSE. So next we show an example with the unequal sample size ANOVA. So this test with 4 groups, 4 treatment groups, and this is the data. You can see the unequal sample size, but of course unequal is not very largely different. But this group has relatively large, and these 3 groups are almost the same. So from blood samples collected from each subject, the serum alkaline phosphate activity level was determined and recorded. So the question is, test the hypothesis at the 0.05 level of significance such the average serum alkaline phosphate activity level is the same for the 4 drug groups. The solution is, so with the level of significance at 0.05, so we established null hypothesis H0 is these 4 group mean are all the same, and alternative hypothesis H1 is at least 2 of the means are not equal. So from the previous table for unequal size ANOVA, we can get the critical level for 0.05 significance, and with the corresponding 2 degrees of freedom, we can get F value is 2.836 here. So if we get the sample F is larger than this value, then the null hypothesis will be rejected. So here we compute 4 mean value y1 to y4, and analysis of variance is conducted in Minitab program. Though this is the output of the Minitab, very similar as the previous video. So here factor is for between treatment variation, and error is the sum of squares of error variation from the random term. So their sum of squares and mean sum of squares is a division of sum of squares divided by the corresponding degrees of freedom. This is the mean sum of squares. Then the division of these two get this F value. So the final F value from the data is 3.57. And we can see that this value is larger than 2.63, which is the critical level. And the p-value for this F is also less than 0.05. So it's quite clear that we will reject H0 and conclude that the average serum alkaline phosphate activity levels for the 4 drug groups are not all the same, because the calculated p-value is 0.022. Thanks for watching.